An LED is a light-emitting diode. A diode is a semiconductive material which allows current to pass through in one direction. It is used to convert AC to DC, that is, alternative current to direct current. In case of AC, the positive and negative get interchanged and therefore the current flow keeps on changing. However, in TVs, laptops, etc., where the current flow has to be in one direction, we need to use DC. Therefore, we use diodes. What is a PN junction? In LEDs, we use PN junction diodes. A PN junction is a boundary or interface between two types of semiconductor materials, P-type and N-type, which are mostly made of silicon inside a single crystal of the semiconductor. The positive side, that is, the P side, contains an excess of electron holes, while the negative side, that is, the N side, contains an excess of electrons in the outer shells of the electrically neutral atoms there. What are electron holes? In a normal atom, the negative charge of the electrons is balanced by the positive charge of the atomic nuclei. An electron hole, often simply called a hole, is the lack of an electron at a position where one could exist in an atom. Holes in a metal or semiconductor crystal lattice can move through the lattice as electrons can and act similarly to positively charged particles. What is a p-type semiconductor? To form a p-type semiconductor, there is an addition of some trivalent impurity such as gallium, aluminium, etc. in the original semiconductor. As trivalent impurity has 3 electrons in its valence shell, and when it creates a bond with the silicon atom, there will be a deficiency of electrons in its valence shell, which is called a hole or an electron hole. What is an N-type semiconductor? To form an N-type semiconductor, there is an addition of some pentavalent impurity in the original semiconductor. As pentavalent impurity has 5 electrons in its valence shell, and when it creates a bond with silicon atom, there will be a surplus of electrons in the valence shell. It is a PN junction diode that emits light when activated. When a suitable current is applied to the LEDs, electrons are able to recombine with the electron holes within the device, releasing energy in the form of photons. This effect is called electroluminescence, and the color of the light corresponding to the energy of the photon is determined by the energy band gap of the semiconductor. Photons. Photons are tiny packets of particles which are visible as light and are absorbed when an electron receives energy and goes to a higher level, that is, a higher orbit, and are released when the electron comes back to its original orbit. But in case of p-n junction diodes, the electron which travels from n-type semiconductor to the p-type semiconductor, it is in an excited stage, that is, it is in a higher orbit. So when it travels to the p-type semiconductor, it releases a photon in the process when it goes back to a lower orbit. The color of the light emitted depends on the band gap, that is, the energy gap between the two semiconductors. If there is a larger energy in the photon, it produces blue light, whereas if there is a lesser energy, it produces red light.